I'm Dave Adamson at GSI Environmental. Today I'm going to give a quick overview of an ESTCP project that our team recently completed, developing a framework for PFAS monitored retention. Now, PFAS, it's a pretty challenging set of compounds, as we all know. My colleague Chuck Newell at GSI, he and I have given a lot of talks on this project, and we like to describe PFAS as sort of the bizarro world for remediation professionals because we sort of have to invert our way of thinking about how to deal with PFAS because we're probably not going to be able to rely on the approaches that have worked for other compounds. So today I'm going to go through an alternative way of evaluating and managing these sites, what that might look like. We call that PFAS monitored retention or PMR, and I'll do that by going through the series of questions that are laid out here. First, what is PFAS monitored retention? What we're talking about is a site management approach that relies on these natural retention processes that reduce migration rates and PFAS mass discharge rates. We have to rely on these because right now there's no evidence that PFAS can naturally degrade to innocuous end products in the environment. So these retention processes are really the primary influence on PFAS fate and transport and serve as our basis. What is the purpose of the PMR framework? So this framework is our key project deliverable. It's a document that's designed to help site managers evaluate the suitability of PMR at a specific site, or if they're looking at a portfolio of sites, to help identify those sites that are highest priority. So it describes the various lines of evidence that are important for documenting PMR and shows how to collect data to support this lines of evidence approach. So this cartoon on the right, it helps demonstrate this. It shows the two primary lines of evidence for PMR that we settled on. On the x-axis, you've got PFAS plume mass discharge and PFAS travel time to the nearest receptor on the y-axis. So we'll talk more about these lines of evidence in a minute, but just think about PMR, it's a more suitable approach for sites in the bottom left. If you think about this as sort of an inverted baseball diamond, then the sweet spot for PMR is in the home plate area, while sites that are farther out in the infield or even outfield, those would need even different approaches because maybe there's a nearby receptor or maybe strong mass discharge that retention isn't addressing on its own. So how does PMR compare to M&A? This is a question we've gotten a lot, and in some ways there are a lot of similarities, particularly in the way that M&A has been applied for metals, radionuclides, and inorganics. Both of these rely on non-destructive processes. The difference is that M&A of metals, rads, and inorganics relies on sequestration or immobilization, and these are considered permanent processes. PMR, on the other hand, relies on retention, where the chemicals are isolated from potential receptors for a certain amount of time, but we're not necessarily talking about a permanent isolation. So some definite similarities, but also some differences. What are the benefits of PFAS retention processes? Well, first, a reminder of what processes we're talking about. If you look at this cartoon cross section, you've got a surface release of PFAS. Then that PFAS is going to be influenced by absorption to the solid phase and to the air-water interface as it makes its way through the vadose zone. Some PFAS can make its way down to the saturated zone. We don't have air or water interfacial absorption anymore, but you do still have absorption to solid phase materials, particularly those longer chain PFAS and PFAS precursors that may have positive charges associated with their head group. So these characteristics make them stickier and retard movement even in those transmissive zones. Then you may also have matrix diffusion in settings where there's a low permeability zone, a low K zone present, where PFAS mass is diffusing into those zones and it's retained, and that reduces the amount of mass that would otherwise be transported down gradient. So collectively, these processes can slow migration, attenuate mass discharge, in part because they have been shown to be hysteretic, meaning that the release is occurring more slowly than the initial loading. So this graph helps to show these effects, where the mass discharge curve in the absence of these retention processes might look like something like the red curve. But retention, what it does is it reduces the magnitude of the peak, causes it to arrive later, like what's shown in that green curve. In effect, it's dampening these effects over time. All right, what types of sites and PFAS are amenable to PMR? We've got some general characteristics listed here. This isn't intended to be an exhaustive list, but what we're talking about generally is sites with relatively low strength sources, probably slow moving groundwater that lends itself to long travel times. Heterogeneous sites tend to have matrix diffusion, which is a retention process for PFAS. Also, anaerobic sites because they're expected to have slower conversion of precursors than aerobic sites. Precursors tend to be more strongly retained than their perfluoroalkyl acid end products, PFAAs. The PFAS characteristics on the right side, those are related to stronger retention profiles. So sites with an abundance of these compounds, those are likely to be better candidates for managing with PMR. What are the lines of evidence for evaluating PMR? Now, I've mentioned the two primary ones already. First, we're talking about mass discharge in groundwater. This is a combination of three factors. So it includes the concentration, the groundwater flow velocity, and the cross-sectional area of the plume. You multiply these things together, you're going to get a mass discharge in units of mass per time. That's a good representation of the strength of the source. The lower the mass discharge, the less likely there is to be an impact on a down gradient receptor. The second is the plume travel time to the nearest receptor. The framework goes through some approaches for estimating this, but the key thing here is that you need to take into account the rate that PFAS may be moving, which may be slower than groundwater itself. Sites with longer travel times to the receptor are better candidates for managing using PMR. There are also secondary lines of evidence that can be used to support the PMR evaluation. So these lines of evidence generally focus on direct field measurements to show how these various retention processes might be active. So this might include estimating KD values using co-located soil and groundwater samples to help estimate retardation factors. It could include sampling for PFAS in low K zones to understand if matrix diffusion is relevant. Might also include a site-wide PFAS mass balance like what's shown in this graphic, that shows the distribution of PFAS in different soil compartments and helps establish which ones are retaining the most mass. And it could also include vadose studies. So maybe you're installing lysimeters to help quantify if there's much PFAS mass still making its way into groundwater. The framework also describes approaches that could be categorized as line of evidence 3. These are mostly modeling approaches to help demonstrate the specific effects of retention processes. So we've got an example shown here in this graph. This is something my colleague Poonam Kulkarni did where she was modeling the PFOS plume concentration with distance from the source. So we had field data that were consistent with the modeling simulations where matrix diffusion was occurring and contributing to a plume length that was about 400 meters. That plume size, and then we did a plume size in a parallel simulation where matrix diffusion was not included, and that resulted in a much longer plume length of about 1,000 meters. So these results are a strong line of evidence that matrix diffusion was active at that site and would be supportive of using PMR, assuming all other conditions were met. All right, so how do you collect data to evaluate these lines of evidence? We realize there's not really a one-size-fits-all approach for everyone. So what the framework has is a tiered approach to collecting data. So a site manager, they might start at tier 1 if a site is simple or they're just looking at a screening level evaluation, might just involve a little bit of data. Tier 2 and tier 3, those might involve collecting additional data, such as a larger number of investigation points to collect mass discharge data, like what's shown in this figure. Then if these initial tier 1 evaluation, if that's promising, that could be a signal to proceed with these higher tiers, particularly at those more complex sites where additional lines of evidence might be more important. This overall process, this tiered process helps make sure that the resources that are poured into investigation and evaluation processes, that those are efficient efforts. Okay, how can the PMR framework be applied? There's really two different ways to do this. And first, this evaluation of a specific site where we're establishing values for the two primary lines of evidence based on their appropriateness for that specific site. So this example shows that using a threshold travel time of 10 years or more, and also a PFAS plume mass discharge values, these ones might seem large at first glance, but at this site, they're based on the fact that the nearest receptor is a very large stream. So there's mixing and dilution of that mass discharging into this receiving stream. The estimated values for this site, they plot with that green dot plots in the zone where PMR is judged to be a reasonable approach. A second application is do a screening level evaluation of a bunch of sites using more generic values, and that'll help you ID where your priority sites lie. So this example uses the same travel time as before, but the mass discharge is based on more of a generic scenario where you're saying the receptor is a drinking water well pumping at 100 gallons per minute, and we don't want the mass discharge to cause the concentration in that well to exceed the MCL for PFOS. So some sites, like the green dots, might still plot in the PMR zone, while others, like those blue dots, might need a little extra enhancement. And we'll talk about that more in a minute. And then the highest priorities are the red dots that plot farther out. And these are the ones that might need immediate action, like a pump and treat system or treatment at the point of exposure. So this type of application, it helps you easily identify where your priorities lie and which site might count. The counter is that it also identifies which sites might not need to be prioritized immediately and could maybe use PMR. All right, what is PFAS enhanced retention or PER? So I mentioned that in the previous slide. The framework goes through various approaches that you could be used to enhance natural retention processes in case where they might not be enough on their own. So the goal, and you can see it here in this diagram, is really to reduce mass loading or increase retention capacity. So you're pushing sites, that were in that blue zone down into the left into that green zone, so that afterwards they're in a better position to be managed using PMR, maybe as a treatment train type of approach. So the most well-established PER method, that's really these particulate carbon amendments that sorb PFAS and keep it in place. But there's other simple things like caps or even more novel approaches that are being investigated at the research scale but might not really have been applied widely. All right, let's wrap up with looking at the primary benefits of the framework. That really includes its use in the supporting the RIFS process. It's supporting the development of remedial alternatives that could include PMR or PER, either as sole remedies or part of a treatment train. So it not only helps the site manager, but it also can help regulators and others who are looking at a lot of different sites and identify priorities, as well as sites that might be amenable to longer term management approaches like PMR. All right, so that's the quick overview. There's a lot more stuff on the ESTCP project page, including links to the framework doc and other publications. So feel free to reach out to me or any of the project team if you want more info or need help. Thanks.